This is a recording, or this is a video of me working through some derivatives. So the worksheet that I'm working on is found in the Canvas, and of course the best way to use this video is to print off the worksheet and try the problem and then watch me do the problem. So here we go. Number one, this is either you can use the product rule, or you could do a little bit of algebra first and not have to use the product rule, which is what I would recommend on this one. So remember, when you're just doing algebra, make sure it's clear that you're just doing algebra. So I'm writing f of x equals x cubed plus, and this is x to the 1/2 times x to the 6/2, so that'd be x to the 7/2. So that's just distributing the x cubed through the parentheses. So then now I'm ready to take the derivative. Take the derivative. That would be 3x squared plus 7/2 x, and 7/2 minus 1 would be 5/2. And that would be the derivative. And number two, once again, it probably makes more sense to just do a little bit of algebra right now because it's not hard algebra. So t cubed times, and this I'm going to think of as 2t to the -1. So t cubed times 2t to the -1 would be 2t squared, and t cubed times t to the 5th would be t to the 8th. And then 2t to the -1 times 1 would be 2t to the -1, and t to the 5th times 1 would be t to the 5th. And there's no like terms, so I can't combine anything. So now I'm ready to take the derivative. So that would be 4t plus 8t to the 7th minus 2t to the -2. Remember, when you're dropping a power and it's negative, it's going to go, the number's going to get bigger because you're subtracting 1 from -1, which makes it -2. And then finally 5t to the 4th. Okay. Number three, again, I could use the quotient rule there, but it's going to be easier just to rewrite this as y cubed plus 2y plus 1 to the -1 power. Notice we can't just apply -1 or negative powers to each individual term on the bottom. You have to move the whole bottom up as one term. So that's why we put a -1 power on the outside of the parentheses. Okay, so now I'm ready to take the derivative. So when I take the derivative here, there's a chain rule application because the outside function is -1, or something to the -1, and the inside function is y cubed plus 2y plus 1, and then of course the innermost thing is y. But so we're going to have -1 times y cubed plus 2y plus 1 to the -2 power. So I'm just applying the power rule there, but then I'm going to multiply that by the inside, which would be 3y squared plus 2 plus 0. So then to simplify that, we really just have to distribute that negative up there, this negative over on here. So that would be -3y squared minus 2 on top. On the bottom, I'm going to have y cubed plus 2y plus 1 raised to the 2 power, because that's what the negative exponent tells me. Okay, and this one I'll do in a similar way. Start by saying x plus x to the 1/2 raised to -1 power. So then y prime is going to be -1 times x plus x to the 1/2 to the -2 power times the derivative of x, which is 1, and times the derivative of x to the 1/2, which is 1/2 x to the -1/2. So once again, distribute that negative, so I get negative 1 minus 1/2 x to the negative 1/2, all on top, and x plus x to the 1/2 squared on the bottom. Okay. Here's the first one where I actually have to use the product rule. So in this case, I have a y equals, you can think of that as your u and that as your v. So that means the derivative of y is going to be u times the derivative of v plus v times the derivative of u. So y prime is going to be u, which is 2 to the x, times the derivative of v, which would be e to the x, plus v, which is e to the x, times the derivative of u, which is ln 2 times 2 to the x. All right. And number 6, this is kind of the first one where I'm forced to use the quotient rule. So we'll jump right into it. G prime of z. So it'd be low, which is 7 cubed minus 5. D high, which would be 2z minus high, which would be z squared plus 1 times the derivative of the low at the bottom. That would be 3z squared all over z cubed minus 5 squared. And of course we can simplify this by multiplying through some things. So we got g prime of z is going to be equal to, so 2z times z cubed, that would be 2z to the 5th. And 2z times negative 5 would be negative 10z. And notice there's a negative right there, so you got to be careful about that. So I'm going to multiply 3z squared times z squared, but it's also negative. So that'd be a negative 3z to the 4th. And I'm multiply 3z times 1, but again, that negative applies to it, so that'd be a negative 3z squared. And that's all over z cubed minus 5 squared. Okay, so number 7, once again, this is going to have to use a quotient rule here because we have 2 terms on the bottom. If it was just 1 term on the bottom and 2 terms on the top, we could do like we did up here. Where was it? Oh, I guess we haven't done one of those on this one. Well, we'll show you when we get down to number 9. We can avoid the quotient rule on that one. Okay. So number 7, you got to use the quotient rule. So we're going to go y prime is low, would be x cubed plus 1, d high, which would be negative or 1/2 x to the negative 1/2, minus high x to the 1/2, d low, which would be 3x squared, all over x cubed plus 1 squared. And of course we can simplify that. 1/2 x to the negative 1/2 times x to the 3rd, that would be 1/2 x to the 5/2 plus 1/2 x to the negative 1/2. And then if we multiply that stuff, that'd be negative 3x to the 3/2 all over x cubed plus 1 squared. Okay, and then number 8, again, I can't avoid the quotient rule on this one. However, I think I would multiply that bottom out first, so I'm going to write this as t squared on top, And on the bottom, I'm going to have 2t minus 8 minus t to the fourth plus 4t cubed. Two times t is 2t, 2 times 4 is negative 8, yep. T times negative t cubed is negative t to the fourth, and positive 4. Yeah, okay. Just checking I did that right. Okay, so then z prime is going to be low, which is, I'll rewrite these in the proper order, so that'd be negative t to the fourth plus 4t cubed plus 2t minus 8 times to the top, which would be 2t minus, oh, I'm going to run out of room here. I'm going to move over a little bit. Sorry about that. So z prime is equal to, so I'm going to have, again, negative t to the fourth plus 4t cubed plus 2t minus 8 times the derivative, which would be 2t minus t squared times the derivative of that, which would be negative 4t cubed plus 12t squared plus 2. Oh, just barely fit it in. On the bottom, I'm going to have a negative t to the fourth plus 4t cubed plus 2t minus 8, whole thing squared. Now I got to simplify that top. Bit of a mess up there. So let's see. I got 2t times negative t to the fourth. That would be negative 2t to the fifth. Oh, but I also have a negative t squared times negative 4t to the third, which would be a positive 4t to the fifth. So that ends up just being positive 2t. Okay. So 2t to the fifth. And I've taken care of that guy times that, and that guy times the 2t. That's where this guy came from. Okay. Now let's see what else we got. We got 2t times 4t to the third, which is 8t to the fourth, but we also have, so now I'm talking about this guy, but we also have a 12t squared times a 2t squared, so that's the t to the fourth also. So that's going to give me, let's see, that would be a negative 12t to the fourth. This is a positive 8t to the fourth. So I end up with a negative 4t to the fourth. What else we got? Adding more highlighters out here. Okay, so then we also have a, looks like a t squared. So this guy here is going to produce a t squared, and that guy there is going to produce a t squared when I multiply it. So that would be 4t squared and negative 2t squared, which would be a positive 2t squared. And then finally, last but not least, we have negative 8 times 2t, which would just be negative 16t. All that is over negative t to the fourth plus 4t cubed plus 2t minus 8 squared. And just so that 16t doesn't leave out, I'll highlight him too. Okay. That was fun. It's always fun to include a little highlighting. Okay, so then the next one, this is the one that I said we could avoid. Quotient rule by just distributing and dividing. So x to the 1/2 power times x to the 3rd power, that'd be x to the 6 halves plus 1. 7 halves divided by 2, so that'd be x to the 7 halves divided by x to the 4 halves, which would be x to the 3 halves. And x to the 1/2 divided by x squared, that'd be x to the negative 3 halves. So I distributed this there and then distributed the divide by x squared. So h prime of x would be 3 halves x to the 1/2 minus 3 halves x to the negative 5 halves. All right, back. So let's see, we're done that. So number 10, once again, we're going to have to use the quotient rule. But notice in the midst of using the quotient rule, we have going to have to do a product rule because the derivative of the top requires a product rule to do it. So in something like this, what I like to do is I'm going to let the top be u and the bottom be v. Then over to the side here, I'm going to say let's figure out the derivative of u. So the derivative of u is e to the m. Oh man, I don't have enough room here, doggone it. Well, let's see, we're going to do this. We're going to make it a lot bigger. Okay. So I'm going to say the derivative of u is e to the m times the derivative of that, which would be 1/3 m to the negative 2/3, plus the derivative of e to the m, which would be e to the m, times m to the 1/3. So that's the derivative of u, or the top. The derivative of v, or the bottom, would just be 2m. So now when I go to calculate the derivative of y, I know that I just need the low d high minus high d low all over low squared. And since I already have all the u prime and the v prime calculated, really all I'm doing now is just plugging these things in. So v, we know, is e to the m times m to the 1/3. U prime is that thing up there. So that's going to be times e to the m. That's going to be times 1/3 e to the m, m to the negative 2/3. Oops. Oh yeah, guys, I don't have any room here. Doggone it. This sheet is so small. Let me rewrite that over here. I gotta make plenty of room for this. Sorry about this, guys. And this one will be simple, so I'll have plenty of room there. Okay, so y prime of m. So as I said, for v is just m squared plus 3, right? Low d high, so the derivative of that would be, so I need a little parenthesis around this. I'm going to have e to the m, no, I'm going to have 1/3 m to the negative 2/3 times e to the m plus m to the 1/3 times e to the m. Okay, and then I'm going to subtract from that the u, which is just the top, times 2m. So that's just going to be 2, of course, m times m to the 1/3, that'd be m to the 4/3 e to the m. And then over, all that's going to be over v squared, which is m squared plus 3 squared. Okay, so let's make sure we're clear on this. So here's u, or v prime, and there is v prime. Here is, I'm sorry, u prime. Here's v prime, and v prime is included in there. Here is u, and u is included in there also, so it's kind of overlap. And then finally here's v, and v is right there, and down there, of course, squared. Okay, so now we got to clean this up by distributing some stuff. Okay, on the bottom I still have m squared plus 3 squared. And on the top, I'm going to have to distribute that m squared plus 3 through the other stuff. Okay, so m squared times that first term is going to be 1/3. Let's see, that'd be 4 halves, m to the 4 halves. And m to the negative 2/3. Or I'm sorry, m to the 6/3 and m to the negative 2/3. So that'd be m to the 4/3 times e to the m. So that's just m squared times that. And then m squared times the second one there is going to be, see, m to the 6/3 times m to the 1/3 would be m to the 7/3, so that'd be plus m to the 7/3. E to the m. And then I got to multiply 3 by each one of those, so that would be plus 3 times 1/3 is just 1. So that'd be m to the negative 2/3 e to the m, and plus 3 m to the 1/3 e to the m, and then minus 2. Oh, hold on a second. I can fit that in over here. We got a minus 2m to the 4/3 e to the m, and we have a 4/3 m to the 4/3 e to the m over here. So we can actually just subtract 2 from that. So I'm going to, what's 1/3 minus 2? That would be 1/3 minus, or another way to say it is 1/3 minus 6/3, so that'd be negative 5/3. There we go. We got it. And I fitted it in. Okay, so now number 11. Let's see, that would be 3 times x. I'm going to distribute that first before I take a derivative. So 3 to the x times x would be x 3 to the x. And 3 to the x times x to the 1/2 would be x to the 1/2. 3 to the x. Of course, I can't really avoid the product rule here because I'm going to have 2 little product rules in here. So actually, you know what? It might be better just to do the product rule at the beginning. So I think I will do that. I'm going to go back up here and just take the product rule right away. The derivative of the first is 1 plus 1/2 x to the negative 1/2 times 3 to the x. And then we're going to add to that x plus x to the 1/2 times ln 3 times 3 to the x, right? And then to simplify, we got, let's see, that would be 3 to the x plus 1/2 x to the negative 1/2, 3 to the x plus ln 3 to the x. Oops. This would be ln 3 times x times 3 to the x plus ln 3 times x to the 1/2 times 3 to the x. We have any common or any like terms? No, not really. Okay. Let me write that a little clearer down here. So that'd be 3 to the x plus 1/2 x to the negative 1/2, 3 to the x plus ln 3 times x times 3 to the x plus ln 3 times x to the 1/2 times 3 to the x. A little bendy there. Okay, so this is just making sure you truly understand the product rule. So f prime of x would be equal to g prime of x times h of x plus g of x times h of x. So if I want to know f prime of 10, then f prime of 10 would be equal to g prime of 10 times h of 10 plus g of 10, whoops, I forgot the prime right there, times h prime of 10. So that would be equal, well, g prime of 10 is 0, so this whole thing has become 0, and g of 10 is negative 4, and h prime of 10 right there is 35, so my answer would be negative 120, 140. And also, this is just making sure we understand the quotient rule. We know that y prime of negative 3 should be equal to low, which would be 1 plus negative 3 squared, d high, which would be z prime of negative 3, minus high, which would be z of negative 3, d low, which would be 2 times negative 3. So what's that going to be? That's going to be 3 squares 9. That'd be 10. Oh, whoops, I forgot the bottom. Oh, that was embarrassing. Hold on, your horse is there, buddy. So on the bottom, I'm going to have 1 plus negative 3 squared, the whole thing squared. Okay. Alrighty then. So just to make it clear, do a little highlighting. That's going to show up right there and there. And that is going to show up right there. And then this is the derivative of the bottom. And that, of course, is the derivative of the top, just like it says. Okay, so now we're going to simplify all this. So let's see, that'd be negative 3 squared is 9, plus 1 is 10, so that'd be 10. And z to the negative 3 is 15, according to my information up there. Z of negative 3 is 6, according to my information up there. 2 times negative 3 would be negative 6, according to that right there. And the bottom looks like I'm going to have 100, because that'd be 10 squared. So that'd be 150 plus 36 all over 100, aka 186 over 100. Well, we can reduce that, can't we? So that'd be 93 over 50. And that concludes our video. All right, have fun.